U.S. Marines to get autonomous cargo helicopter. The U.S. Marine Corps is getting a drone that can haul cargo into contested territory without putting a single crew member at risk, and the Pittsburgh company building it just received the contract to prove it works. Naval Air Systems Command awarded Near-Earth Autonomy, the MARV-EL Increment 2 program, on April 28, 2026 under an other transaction agreement through the Naval Aviation Systems Consortium. MARV-EL stands for Medium Aerial Resupply Vehicle Expeditionary Logistics, and the name tells most of the story: an autonomous helicopter-type aircraft designed to move supplies to Marines operating at the tactical edge in places where sending a crewed helicopter means accepting risks that commanders increasingly cannot justify. Near-Earth will lead the effort in collaboration with Bell Textron Moog and XP Services. The platform at the center of the program is the Bell 505, a proven commercially available light helicopter that the team is converting into an autonomous cargo hauler. Near-Earth's contribution is its Captain Autonomy architecture, a safety-critical software framework that handles autonomous takeoff, on route navigation, obstacle avoidance, GPS-denied navigation, safe landing, and dynamic in-flight mission updates. Moog's Genesis avionics and certified flight control system connect that autonomy to the aircraft's physical controls with what the company describes as high-integrity flight control. XP Services handles the physical conversion, work modifications, integration, maintenance, and experimental flight testing across every stage of development. The Marine Corps' logistics problem that MARV-EL is designed to solve is real and growing more acute under distributed maritime operations and expeditionary advanced base operations. The operational concepts the Corps has been developing for large-scale conflict in the Pacific. Marines spread across dispersed island positions and remote outposts need sustained resupply. The further and more dispersed those positions, the harder and more dangerous conventional helicopter resupply becomes. Crewed aircraft face not just enemy threats, but the grinding arithmetic of crew cycles and force availability limits during high-tempo, around-the-clock operations. An autonomous aircraft doesn't sleep, doesn't accumulate fatigue, and doesn't require a pilot to accept the risk of flying into a contested area to drop off ammunition or food. Near-Earth CTO Lyle Chamberlain put the program's intent plainly: "We are combining our Captain Autonomy architecture with a proven Bell 505 platform to move cargo without putting Marines in harm's way." The design philosophy extends beyond the aircraft itself. Chamberlain noted that the system integrates with existing Marine Corps command and control workflows, including MAGTAB and MENGL, so operators can request dispatch and manage missions through familiar interfaces rather than learning new systems from scratch. On the ground, cargo loads using standard pallet jacks and forklifts, no specialized equipment required. The program builds directly on Near-Earth's existing track record with the Marine Corps and beyond. The company previously worked on the Tactical Resupply Unmanned Aircraft System and the Aerial Logistics Connector programs with the Marines, and its Captain Autonomy framework is the same architecture being applied to the Army's RUC-60 optionally piloted Black Hawk helicopter program. That cross-service lineage matters. It means the autonomy stack isn't being invented for MARV-EL, it's being extended. Near-Earth claims more than 13 years of aerial autonomy development, over 10,000 flights, and more than 140 airframes, a foundation that started with the Autonomous Aerial Cargo Utility System program, which first brought rotorcraft autonomy to Marine Corps resupply. Chief Strategy Officer Samuel Dinner framed the team's approach as deliberately conservative in the best sense. "Our approach optimizes for fast, efficient progress on a mature OEM-supported aircraft rather than slowly reinventing the wheel with a new vehicle." Bell Textron brings the 505 platform along with its technical data and airworthiness documentation, which provides the foundation for derivative military configurations. Moog's flight control system bridges autonomy software to the physical aircraft. XP Services, a modification and flight specialist operating since 2008 with hundreds of aircraft conversions on its record, handles the hands-on engineering work of actually turning a commercial helicopter into a military autonomous logistics platform. The performance targets are demanding. The awarded contract requires the system to meet MARV-EL threshold requirements for a 1,300-pound payload at a 100 nautical mile combat radius. Near-Earth's proposal outlines a configuration designed to exceed certain objectives beyond those thresholds, including greater payload capacity, room for a full-joint modular intermodal container, longer combat radius, and transportability efficient enough that 2 aircraft fit inside a C-130 with minimal disassembly. That Last detail matters enormously for expeditionary operations where getting equipment to a forward base often depends entirely on what fits inside an airlifter. The program timeline runs 36 months, during which Near-Earth will integrate and flight test the autonomous system, progressing from early demonstrations through to full mission capability, while helping the Marine Corps develop the operational procedures that will govern how autonomous aerial logistics actually functions in the field. Bell's SVP of Engineering Jason Hust called the Foundation Strong Moog's avionics general manager Sharmila Durairaj pointed to a proven path for contested operations. XP Services Program Manager Ken Flegger cited hundreds of prior conversions as evidence the team can deliver at pace. 36 months from now, if the program delivers, a Marine at a remote Pacific outpost will be able to request a resupply, and an autonomous helicopter will fly it in. No pilot needed, no crew at risk, no crew rest clock running.